Hello students, good evening everyone. So in the last video, that is fundamental physics part 1, we discussed about the some fundamental quantities, supplementary and derived quantities. Few we discussed. In this class we are going to discuss more derived quantities. In that, first let us see children regarding the distance. So to understand the distance, first we need to know what is the path. Right children, see many times when day-to-day life we'll use the word path. So what is the meaning of the path? See, path means, suppose imagine children a bus or something above object A or U. You're standing at one place, you will go after 1 minute, after 2 minutes, after 3 minutes. Suppose you will go in this path. This is the first position, second position of you. In the third minute, this is your position. So different times you will be in different places. So the line chaining all the successive positions. This is what children, this are first position of you, the second position. So the line chaining all these positions, what we call as a path. Or else if you take the curved path, first position, second position, third position, fourth. So whatever may be the path, maybe parabola, curved path or any kind of the path. The path means the line chaining the successive positions of the particle, what we call as a path. Understood children? Path means the line chaining all the successive position, that is what we call as a path. So we can take go from one village to another village. Let us take A to B. Whether you can take shortest path or you can take longest path or more curved path we can take or circular path, whatever. So path means what? It is a line joining from all the successive positions. Suppose in a first minute, second minute, third minute, if a bus is in a first, we suppose Bangalore to Mumbai bus we need to go means different places we need to cover. So in all the places, the line joining all that places, that is what we call as a path from Bangalore to Mumbai, like that. So let us learn children what is the path. I hope it is clear. This is a line chaining successive positions of the particle. Like this, distance means what? Distance is children the length of the path, the total length of the path of the path. So this is what we call as a distance. Understood children? The total length of the path, what we call as a distance. So this distance, usually see children, if it is a distance is there from here to here, one village to another village. You might have heard using the word like measuring the distances in kilometer. We can tell no, from one village to another village it is there 10 kilometers. Or suppose the distance between the two walls in your room, it will be like meters. Or distance between the centimeter lines in your graph sheet. Suppose you saw your graph sheet, right children, to draw the lines. So in the graph sheet, each box length will be 1 centimeter we can use. So like that, distance means we can measure in different units, but distance means what? Total length of the path we can write. Or distance we can measure in the meters. So that's why we can write SI unit. So it is nothing but length only, no? The length. Length is SI unit is meter. That's why distance also, the SI unit of distance is also meters. We can represent the distance using the symbol S. Please remember children, in kinematics, this where we will study actually in the physics the branch is to study the motion of the object. That is what we call kinematics. So in kinematics, we're going to word this terminologies. The distance means we can use a word or letter. The symbol will be yes. That is SI unit will be meter. And I also told dimension formula, right? Dimensional formula of distance. Okay, or we can use a symbol now onwards. It is yes. Distance will be, we can write meter. Meter means it is length. That is L1 only. Like length. What is the dimension formula? It will also having the same dimensional formula. Hope it is clear children what is the distance, right? The next point is the displacement. Displacement. So distance and displacement, the words almost looking like similar, but there is only one small difference between distance and displacement is. So distance means we cannot consider the which direction we are going. So whichever direction distance will be, if you go from here to here 4 meters, or if you come from A to B or B to A also, we can tell it is 4 meters only distance, that is. But displacement comes, displacement, it is depends upon direction. Suppose you need to reach from point A to point B, so you must go in this direction only. So if a direction towards the east you will go, So then only you can reach that destination. Suppose in a world map, you have taken a map, you need to go from one country to another country, you must follow the direction. If you go in this direction towards north or towards south, which direction if they specify, if you go in this direction, then only you can reach your destination. So displacement gives you the how much distance is there plus the direction, which direction it goes. So displacement we can simply write as, it is nothing but like children, distance plus direction. So it will give the information regarding the distance and also the direction. So displacement is a one, it is a one simple meaning, and displacement is also called line segment. Line segment between initial and final points. Line segment between initial and the final point, or is also called the straight line distance. Straight line distance between initial to final point. This is also called as a displacement. Let us see one figure, children, displacement, to understand it properly. Okay, let us take the point A is there. Okay, just imagine best example. Let us see, children, an electric pole is there. On the electric pole, one bird is sitting. Now on the ground, one ant is there. Okay, imagine on the bird, on the ground, one ant is there. Here the bird is sitting. It need to catch the bird. So how the bird will go here, ant? So it won't come down because it's a bird, right? It can fly. So it will directly come from here to here and catch the ant. So here it will travel what, children? Straight line distance. The straight line distance, or it's a line segment. Line segment means having one end and containing the direction. Okay, one from the end, one end point containing one ray like a arrow mark. So this is what line segment. So here it is a straight line distance it will run. So this is what we call as a displacement. But distance, suppose ant need to reach the bird, to bite the bird, ant need to go. How it will go? It cannot fly. So definitely it will go like this, and again it will reach here. So let us say this is 3 meters are there, it is 2 meters are there. So ant need to cover total 5 meters to reach the bird. But bird, what happens, children? It will take straight line path, no? So it directly come from here to here. It may be less than this, okay? Less than this distance, maybe 3.2 distance meters only enough, so that bird can reach here. So this is the shortest path what we can call displacement. Or else let us take from one village to another village. Let us take honeybee sitting in one flower. It will go to another flower. So honeybee, you know, no honeybee or a butterfly, it will take their own path. So different paths they can travel, this path or this path. Sometime maybe it will come like this also, or like this also. Any direction, whichever path it would want, it can take. So here we can see from A to B, which is taken the straight line path. This is what we call as a displacement. So it is the shortest path or the straight line path. What we call, let us take, this is 2 meters, but here it is take 3 meters or 5 meters, or it will take 6 meters. All are distances. Okay, even displacement is also called as a distance. But here displacement means shortest path, what we call as a displacement. Even displacement also we can measure it in terms of length only. This is also one of the kind of length only. So it is nothing but SI unit will be, SI unit is meter only, and dimensional formula is also same as the distance, that is L1. And see children, the displacement we can use the symbol S bar. For distance we are using S, and displacement we are using S bar. Hope it is clear, children. Distance and displacement. Let me write differences of distance and displacement. How much you clear? Let us test distance and displacement. Right? See children, distance we can write, it is nothing but total path. Right? Distance is nothing but what? Total length of the path. Total length of the path. This is what we call as a distance. But displacement is, it is a straight line distance. From where to where? From initial point to final point. So this is what we call the displacement, or it is a line segment. Line segment from initial to final point. So this is also called as a displacement. Hope it is clear, children. Distance and displacement, this is only difference. Sometimes children, distance may equal to displacement. Okay, sometimes distance is equals to displacement also, but displacement never equal to, sorry, it will be always greater. Let us imagine children A and B. It will come here. This is also called as a distance and displacement also. Displacement, okay, and it will be also called as a distance also. Okay, sometimes distance may be, so let us take distance symbol is S, displacement symbol is S bar. It does not depends upon direction. Okay, does not depends upon direction, and here it will be depends on direction. Depends on direction. It will be depending on direction. Now see, displacement A to B. Suppose object need to travel from A to B. It will take this path. This is also a distance. And this will go from here. It is also called as a distance. See, distance, this is a center line is, what is called straight line. This is also called a distance. See, in the first figure, in the center line, where, what is that children? Let us take 2 meters, where distance also is equals to displacement. But distance is always greater. It is a 2 meters, it is, suppose it is a 3 meters, it is 4 meters. You observe, distance is always what? Distance is always greater than displacement. Okay, distance is always greater than displacement, or sometimes it is equal also. So we can write the conclusion that distance is always greater or equal to displacement. It never less than distance displacement will be never less than the distance. Displacement is a smaller one, distance is only larger quantity. Hope it is clear, children, this concept, distance and displacement. And we can also write one more word here, that distance will be the scalar quantity and displacement is vector quantity. So why we going to differentiate scalar and vectors? So in the physics, we're going to use these two words also. I'll explain this in the next slide, children. See, scalar and vectors. See, the word scalars means it won't depends upon direction. In the physics, we can divide the physical quantities into two bases on two types. One which does not depend on direction and one which will depend on direction. Does not depend on direction. So here they will depend on direction. Suppose imagine children, your friend is there, you will tell your friend from here you will go 2 kilometers. Okay, from here you will go 2 kilometers, then you will get a school. Okay, only that information is given. Is it sufficient, children? Because here to 2 kilometers, maybe he will go in this direction, in this direction, in this direction, whichever direction he want. But all the places, if he'll go towards the east or west, or towards the north, or towards the south, he won't get the destination or the school position, right, children? Only when he go towards the east, then only he will get the school position. So where only distance, if you specify some of the factors, distance is not like only magnitude, what we call. Okay, that is not enough. That time what we require, along with the magnitude, along with some number, like how many times you need to go, we have also specify the towards east. Like we need to tell how, children, you will go 2 meters towards east, then you will get the school. So like that we have to specify some quantities required in the physics, where we actually tell the direction also. So that quantities will comes under the vectors, and which does not depends on the direction. Let us imagine, children, mass of the block. I can tell this mass of the block is 3 kgs. Enough. There is no any direction required. If you go in this direction, if you go this direction, if you measure any weighing machine, mass of the body never changes, because it's an internal property, right? Amount of quantity present. If you take this, it does not changes anywhere. So is a mass is what, children? It is a scalar quantity. Okay, mass is what? It is a scalar quantity. Like that, distance also. We want only distance between the two villages. We can tell it is 10 kilometers is there. Okay, so distance between the two villages is 10 kilometers. So this distance does not require any direction to specify. Enough 10 kilometers we can know. But suppose you are there in Bangalore, you need to go to Mysore. That time definitely you need to specify from Bangalore 10 kilometers towards east you will go, then you will get the Mysore. So like that we have to tell the direction. That is what? Displacement, it is depends upon direction as well. Understood, no, children? Here that means we can write here, does not depend on direction, it will depends upon direction. Here that means the word what is the here 3 and here 10, that words what we call magnitude. Magnitude means it is some kind number or constant number. Magnitude. So magnitude and direction is there, and direction both it will be dependent. Vector quantities having both magnitude and direction, they are called vectors, and they have only magnitude, they don't have any direction, only magnitude they have, they are called as scalars. Hope this is clear, children. Conclusion: what are the scalars and the vectors is very important for physics. They will ask some quantity, they will give physical factor, tell me what is this, whether scalar or vector, they can ask. So you need to know idea why you call them as scalars, because they does not require to specify the direction, and which quantities will require the specified direction. So that based on that we divide this. I hope this is clear, children. Yes, right. Let us understand based on the distance. See children, if you have march fast or running race, suppose imagine two persons are started in the track, they need to run the running race they kept. Okay, so this is a final destination point, just imagine. So person A and person B both have started the race, and he will go faster and he will go slow. Okay, who will reach the destination first, children? Who are going fast? Exactly right. Your answer is right. So what you are guessing is correct. Who will go fast? Definitely he will come first place, right? And who will go slow? Who are coming slowly? Definitely he will come at the second place. Why? Because the distance is same here. Distance is same, like a 10 meters or 100 meters race we played. Here also 100 meters only. Distance never changing. But what is changing, children? He is coming fastly, right? Fast means he is increasing its time. He will come with the less time and he will come with the more time. If a distance is same but the time here taken more time, sorry, here he taken a less time and here he taken a more time. So who taken a less time? Let us take in a time of 2 minutes only he reached this, and in a time of 5 minutes he reached this. Who will taken a more time, he will be a slow person, or we can call. So here is a one quantity is there which define the both the quantity speed and the time also. That quantity in the physics what we call has a the term called speed. Clear children? The word what we call that has a speed. So speed gives you the how much distance you traveled, how much distance traveled in a given interval of time. So distance traveled by time. So you have heard children in your parents are telling you the speed limit in the highways will be like 60 kilometer per hour, or in a for the bikes it will be in this track it will be only 40 kilometer per hour. So this is what we are representing, what it is a speed only, right children? And you can see in your bikes there is a term called a speedometer, the instrument called speedometer. Here it will containing kilometer per hour, and it will be one Nile is there, it will be rotating, like it will come 100, 60, 40 like that. So this needle will show what speed your bike or what speed your car is going. This is a speedometer. Okay, it will give us what children, what speed your bike is going. So speed means what? How much distance traveled by time taken. Understood no children? The word speed we can write it as distance per unit time. Okay, distance traveled per unit time, this is what called as a speed. So if you cover more distance in a given time, suppose imagine in a time of in a time of 10 minutes, okay, in a time of 10 minutes the two persons are there, okay, person A and person B, let us say person C and person D. Person C covers 2 kilometers or 2 meters, and person A travels only 1 meter. Now think children, who is fast or who is having a more speed and less speed? Definitely right, who cover a more distance, okay, who cover a more distance, they will be having more speed here, okay, more speed. And who having the less distance in a given time, they will having less speed. So speed also directly proportional to, okay, speed we can use the symbol small v, okay. To represent the speed, we will use the symbol is small v. So the speed is directly proportional to distance traveled. And the speed is also, see from this example what we can say, speed is, if you take more time, then your speed will be less, right? Suppose in this example, if you take children in a time of 5 minutes, this example, if you take more time, your speed will be less. So it is inversely proportional to the time. So combine these two equations and write the speed will be depends upon distance traveled by time taken. Okay, speed will be depends upon distance by time, and the SI unit of speed so far we learned it is meters, and the time we can measure in seconds. So it is SI unit will be meter per second. Understood, my children? The speed we can represent using the small letter v, that is given by distance by time. Distance by time, SI unit. Okay, SI unit is meter per second. Meter is for distance, second is for time. Our dimension formula is, children, for meter it is a L1 and for a time it is T. So combine this and write, if you will get L, if a T will go up, becomes T power of -1. Understood now, children? Anything is a down, it will go up, becomes x power of -1. I hope you learned this in maths. Okay, so this is what will happen. L T power of -1 is a dimensional formula of speed. Now, see children, this is a distance, depends upon distance, right? Speed will be what? It is depends upon distance by time. Since distance is what, children? It is a scalar quantity. It does not depends upon direction. So your speed also, suppose your bike has the limit of 60 kilometers, whichever direction you will go, the limit will be same. It won't change. Okay, the distance, the speed factor never changes in any direction. So we can tell the speed has is a scalar. It is because it have only magnitude. Like we can tell 10 kilometer per hour. That's all. We cannot tell which direction is not required at all. So that's why the speed quantity is called a scalar quantity. SI unit is this and dimension formula is this. Okay, all these are very important terms required to understand the higher class physics. Right, children? Next, let us learn one more concept. Okay, like see, I told you displacement is depends upon direction. That means it will use when distance, for the distance, if you are direction, okay, if you will get the displacement. Like that, children, for the speed, okay, for the speed, if you add direction, then that what we call as a velocity. Hope it is clear, children. Velocity will get. So what this velocity term called actually? Velocity we can represent using v bar, because it is depends upon direction. No, we can put v bar. Like displacement, how it is distance and direction. Like the speed, velocity also speed and direction. This is how we are going to represent. So velocity will be, because it is direction factor, no. So it will be depends upon displacement. Displacement by time. Clear, children? It is displacement by time. Again, the SI unit of displacement is also meter. Okay, SI unit of displacement is meter and the time will be seconds. So we can write meter per second. And dimension formula is, for meter it is the L and for the time it is T. So if T can take up, it becomes -1. So for the speed and velocity have same SI unit and same dimension formula. What is the difference is that only the factor called direction. Hope it is clear, children, regarding the velocity. And velocity is what quantity? It is the vector quantity. Why it is vector? Because it will be depends upon speed as well as direction. Since it have both magnitude and direction, so this quantity what we call as a vector quantity. Hope this is clear, children, everyone. Okay, right. Then next concept we're going to understand important thing, that is acceleration. See children, in your bikes you have at the pedal like structure, like round kind of thing. With your hand you can rotate that pedal like structure. So this is what we call accelerator. If you rotate more, the bike will go with a high speed. If you rotate less, bike will go with a less speed. So what is this word like rotator called accelerator? You can tell, no? Accelerator means it will increases the what rate the speed will be increasing, at what rate the speed is decreasing. We can tell. Suppose imagine you are in the station, okay, as a railway station. Imagine it is a platform. If a rail is in the platform, what will happen, children? It will go very slowly. So it will go very slowly. After some time, what happens? It just increases. When it will come to normal track, there is no flat normal, like it is a railway station, and the station it will maintain the slowly. After it come to normal platform, it will increases the speed. Here it is 2, 3. Here increases to 4, again 5, like that. Again one more station is there coming. Again it will decreases to 2, 1, 0. Again it will come to stop, right, children? So this is what the condition. Or else let us take your bus also. It will, in the bus stop, it will just starting. Initially speed will be 0, 1, 2, like that, starting increasing. When it will come to highway road, the speed is very high. Again, suppose imagine one signal will be there. So what happened? Decreases the speed to again 0, 1, 2, like that, and again it will come to stop. Now you can see, children, the term, the speed, it is increasing, decreasing with the time, in a given time. So there is a factor required to relate this in a given direction, how the speed increasing and decreasing with your time. That is, the term is given by the acceleration. Acceleration is given by, acceleration is represented with the symbol A, and it will also depends upon direction. That is given by actually velocity, or in a proper sense we can write change in velocity. At what rate velocity is changing, we can write change in velocity in a time. Okay, children, change in velocity over a time, that is what acceleration. And here, since it is a velocity, velocity is a depends upon what, children? Direction. So acceleration is also depends upon direction. Imagine one car is there, children. Okay, initially it is going, okay, initially it is going with the some speed, let us take that is u, we can take. After some time t, it will go with the speed of v. This is a final velocity is v. Okay, if the initial velocity is u, final velocity is v in a given time, then what is the acceleration? So to write like this term, we can write final velocity, what is there, minus initial velocity divided by change in time, or how much time it will take, that we can write, children, actually. Okay, suppose imagine initially it is starting from 2 meter per second, and after finally it will reach to 5 meter per second in a time of let us take in a time of 3 minutes or 3 seconds. What is the acceleration? So we can find finally is 5 meter per second, initial will be 2 meter per second, divided by time will be 3 seconds. So we can write 5 minus 2 is 3, divided by 3 gives you 1. Acceleration will be 1. What is the unit? See, velocity unit is meter per second and the time unit is second. So this time again it will go here. So what will happen? Meter per second square will happen. Hope it is clear, children. So SI unit will be 1 meter per second square. Is it clear, children? All everyone? Acceleration we can write like this: change in velocity over time, that is given by this one. And this quantity since depends upon velocity. Velocity is a vector, so acceleration is also vector quantity. Vector quantity. Why? Because it is also having both magnitude and direction. Yes. So acceleration is clear, children, everyone. So this is about the acceleration term. Right? And suppose the speed is increasing. If the speed is increasing, that is what we call actually acceleration. Suppose the speed is decreasing, that is also called, the word has a retardation, or it is called as a deacceleration. Deacceleration means what? If a coming to stop, if a body is, any body or any bike is coming to stop, in that condition what happen? Speed decreases. When the speed decreases, so in that condition what happen? Direction of acceleration will be opposite direction, and that is nothing but retardation or deacceleration. So opposite of acceleration, that is what we call retardation. When it increasing the speed, acceleration, decreasing the speed, called retardation. Suppose imagine bus is going in a given a time, it will go high speed again, distance traveled is increasing, speed increasing, again it will slows down, so again speed will be decreasing. So in this meanwhile, this is what we call acceleration and this is what we call retardation or deacceleration. Hope this clear, children? Right. So after this, we are going to understand one more new concept that is important to your life. What is that? Is nothing but the force, the quantity called force. Right, children? See, we wanted to do anything. Okay, suppose some block is kept here, any object is kept on the table or the floor. So definitely you must apply something so to change its position. Or you wanted to take this object and keep somewhere, you need to displace the object. So from here to here, you need to displace this object. So, or you need to push this object, or you need to take it and keep here, or you need to take from down to here, you need to take any object. Definitely, you have must apply. Okay, right, children? You must apply what, children? You must apply some force, right? If you don't apply force, the object will move. No, right? It is not at all possible. So you must apply some force, then only object will displaces. If object displaces, then only force will be, force must apply. So here force, see children, actually here balanced force and balanced force. Actually two types we can tell. Suppose imagine here one block is there. There are two friends are there. Let's imagine tug of war. Okay, tug of war. Here rope is pulled by two people. Here also rope is pulled by two people. If they are pulling the both and equal force, here also with the 2 newtons of force, here also 2 newtons of force. If you pull, the block does not move any side because equal forces in acting in opposite direction, so it will cancel out. So best example, see children, rope is there. So here two children are pulling, here also two children only pulling, having the same energy. Just imagine the rope does not move to any end. This is what a condition like balanced. Suppose imagine one side that four children are there, one side two children are there. Definitely they can easily pull the rope. This is what we call unbalanced, not equal. Unbalanced force. Here equal is there, so it is a balanced. Hope it is clear, children. So when body need to move, okay, if you apply balanced force, both the ends, suppose the four ends also I'm applying equal force, is the body will move? No, right? Both ends apply equal force, body does not move. If one side apply more force, one side less force, then body starts moving. That means if a body need to move, okay, if any body need to move, we must apply what, children? There must require unbalanced force. Unbalanced force. And or we can take force is nothing but what? Interaction between the bodies. When you just touch, then only you can able to apply. Without touching or without field force, we cannot take the object. So unbalanced force is required to make the body to move. So if you apply unbalanced force, what will happen? Body will undergo accelerate. That means the speed of the body will increase or decrease. That is nothing but what? Acceleration. This unbalanced force will cause the acceleration on the body. Okay, force is one of the physical quantity. Clear, children? Force is what? Force is also one of the physical quantity. We can actually measure this physical quantity using the spring balance. This is a device, you can search in it, you will get the spring balance devices. We can measure the force directly using the spring balance, or indirectly measuring acceleration, measuring mass, we can find the force also. So force, however, we can measure. So it is a physical quantity called derived physical quantity. So what is the definition of this force? Force is a physical quantity which can change, okay, which can change state of rest or uniform motion of the body. Okay, what is the state of rest or uniform motion mean? State of rest means if a body is at not moving, its speed is 0, it is at just rest position. Okay, now you need to change it to motion. If need to, suppose a box is there, a ball is there, you need to kick, right? Then only box will move, or you need to kick the ball, then only ball will move. So you must apply some unbalanced force on this box, then it will start moving, right, children? Unbalanced force must be required so that box will start moving. So unbalanced force is required for that. So, and what is the uniform motion? Uniform motion means, imagine the planets, they will be in the uniform motion around the sun. Or else if a body, if it was a frictionless floor, imagine there is no any friction from the ground, well, keep on moving. This is what with the uniform speed and constant over the time, it will go with the same speed, that is called uniform speed. If a body need to go in the uniform speed also, force is not required. To change from its uniform state to rest position, suppose ball is coming here, to need to stop the ball, you must apply some force, then only ball will come to stop, right children? Whether to make the body to move or whether body to moving body to stop, we must apply the force. Okay, that means force can able to change the state of rest or uniform motion of the body. Not only this children, even force can change the shape of the body. Let us imagine plastic bottle is there, when you apply the force, it will squeeze like this, our paste will come out from the paste toothpaste. By applying the force, shape of the body will change, and the state means state of rest or motion will change, and the shape, size of the body even can varies with the applying force. Okay, and the speed, if the body is going slowly, it make it to fast, and fastly make it to slow. By applying the force, we can do it. Understood children? And even we can able to change the direction of the bodies. It is ball is coming in this direction, if you put the force, you apply force here, it will go to this direction. Okay, you can play the cricket, right children? So when a ball is hit by some person, if you hit in this other direction, the ball will go to this direction. Even you can able to change the direction also. So all this what we call as a force. The force can able to change the state of rest or uniform motion or shape, state, size, all this can, force can change. Understood, right children? So the force is also important term, derived quantity. And the formula wise, according to Newton's second law, we will going to understand and derive this later. But time being, you remember children, the force is given by mass times the acceleration. Okay, if a small ball is there, if a mass is only 1 kg, so if you apply only 2 newtons of force, so that the body will accelerate. Okay, if a mass is there, 10 kg of mass is there, if you apply only 2 newtons of the force, body does not accelerate, only it won't go. So that time what you need to do, you need to increase the force to again 10 newtons. That means if a mass is more, force will be required more. Okay, if mass is less, force required will be less. Okay children, and if a small ball is there, same force you apply to small ball, one big ball, so it will go with the high speed, that is how much acceleration, it will go with the less acceleration. That means acceleration you wanted to increase, again you need to increase the force. Okay, if acceleration will decrease, force must be decreased. Okay, so force depends upon how much mass the body is and what acceleration body is going. So product of both mass and acceleration, that is given by the term called as a force. Hope it is clear children regarding the force. Okay, thanks children, thanks for watching. In the next video, we are going to understand the other important factors in the physics like energy, pressure and other physical quantities. Thank you children.